Here we go. So if you haven't done this, make sure you pause the video and do it on your own. Otherwise, I will show you how to find the first four derivatives of these two functions. Let's begin with f of x equals 9x squared. We're going to utilize the power rule a lot in this one because 9x squared is a polynomial. So the first derivative, f prime, will be 18x to the first power, or just 18x if you want to write it like that. If I take a derivative of that, I get the second derivative. So f prime prime is equal to 18. The third derivative is f triple prime, or the third derivative of f. And the derivative of a constant number we know is always 0. So the fourth derivative, f to the fourth derivative, derivative of 0. Some people get this mistaken. Some people will write does not exist, but in this case, it's still 0. 0 is a constant number. So the derivative of any constant number is 0. So the derivative of 0 is 0. Don't get confused there. Oftentimes I'll see people say, oh, the derivative of 0 doesn't exist. No, the derivative of 0 is 0. 0 is still a constant number, and that means the derivative of that constant number is 0. So the first four derivatives you see here of f of x equals 9x squared. 18x is the first derivative, 18 is the second derivative, 0 is the third derivative, and 0 is the fourth derivative. All right, so the second function we were supposed to find the first four derivatives of is natural log. This one we have to use our natural log rule. So the first derivative of g is going to be 1 over x. Now, 1 over x, in order to take a derivative of 1 over x, it's a lot easier to realize that 1 over x is the same thing as 1 times x to the negative first power. So if we utilize this way of writing 1 over x, then it's going to be a lot easier to take the second and third and fourth derivatives. So the second derivative, I'm going to utilize negative exponents. It's a little bit easier. So I take the -1 times 1 and get -1. I reduce the exponent by 1, and that makes the exponent a -2. For the third derivative, g triple prime, -1 times -2 is a +2. And when you take the exponent and reduce it by 1, you end with a -3 as your exponent. So a +2 is the coefficient, and a -3 is the exponent. The fourth derivative is going to have an exponent of -3 times 2. I misspoke. It's going to have a coefficient of -3 times 2. And the exponent is going to be 1 less than -3. And so 1 less than -3 is a -4. So the fourth derivative is going to be -6 times x to the -4. One thing I want you to see is that if you keep on this pattern, notice what's happening. Each time the x has an exponent that's going down by 1, and we're switching back and forth between coefficients which are positive and negative. So my negative and positive coefficients are always switching back and forth between each derivative. So those are the first 4 derivatives of the natural log function. And if you wanted to, for fun, you could keep going and on and on and on. And that means this is the end of this section.